Hello everyone, welcome back in this the why behind what, in which I bring one JEE Advanced question, the PYQ question, and I try to solve in a different ways or explore a little bit deeper to understand mathematics. So the question for today's episode is the question taken from JEE Advanced 2022 paper 2. This question is from matrix and determinant. The question says that let beta be a real number here, and there's a matrix provided. So this matrix has the elements beta 0 1, 2 1 negative 2, 3 1 minus 2, and for this matrix there is a one expression given here and says that this matrix is a singular matrix. And so by using this information we have to find out 9 bit. It's not a difficult question if you just look at straightforward by taking the determinant of this entire matrix and just simplifying it, you get the answer directly. So what is this first way? I want to explain it first and then we'll go to the different method. So the idea is this: if you take the determinant here, that should be 0, and from there I'm taking e to the power 5 as a common factor, and you notice that this is now one matrix e to the power 5, and this combinedly as a one different matrix. It means I can say that the AB determinant is equal to determinant of A into determinant of B. So I'm using this fact. So I'm writing determinant of A to the power 5 into determinant of A square minus beta minus 1L A minus beta I determinant. Now since determinant of A is already negative 1, I can use this fact here, and so determinant of A to the power 5 is also negative 1. And this is going to be 0 because already this factor is contributing non-zero number. It means now I am with this equation, actually simplified one. So if you take the factors after expanding and all these things, we get two factors. So A plus I determinant is 0 or A minus beta I determinant is 0. Now already we know A, so all that we have to multiply beta with identity matrix and find the difference of this A minus beta I, and from there we equate with 0 the determinant of it, and directly we get beta is equal to 1 by 3, and then 9 beta is 3. By the way, this factor determinant of A plus I is going to contribute nothing, because this will be the absurd. This side will getting the non-zero value and right hand side is 0, and this is independent of beta. You can see that the beta plus 1 times this minus this will become 0. So this is one way, is straightforward, but we want to go deeper in this video. Not that much deeper, but still let's see how we can do it by using the eigen value, or not precisely, the characteristic equation and the trace of the matrix and all those things. So let's see. The idea is this: if I have this A matrix, is a 3 by 3 matrix given. So for a 3 by 3 matrix, I have the characteristic equation is like lambda square minus, let's say this S, not lambda square, lambda cube minus lambda square, S lambda square, S1 let us say, plus S2 lambda minus determinant of A is equal to 0. What is S1? S1 is the trace of the matrix, and S2 is the sum of minors of diagonal entries. So what do we do here? That we find the sum of the minors of each of the diagonal entries, what we see as a beta 1 and negative 2, and find the sum. That will give you S2. So let's find first the determinant, or determinant already we have found, so let me use it. Determinant of A is already negative 1. Now characteristic equation, if you want to write, that will not characteristic equation, this is the characteristic equation, and by the Cayley-Hamilton theorem, every matrix will satisfy its characteristic equation. So this means that the A to the power 3 minus S1 A squared plus S2 A minus determinant of A times A should be, not A, determinant of A times I should be a null matrix. So this is our characteristic equation, and this characteristic equation in the place of lambda we can substitute a. But let's try. Now our task is to find out S1 and S2 because determinant of A already I know. So what is S1? The trace of the matrix, that is beta minus 1, because trace means the sum of the diagonal entries. So beta plus 1 and minus 2, that will give you beta minus 1. And the S2 means the sum of the minor. So what is the minor of beta? That is 0. What is the minor of 1? Minus 2 beta minus 3. Minus 2 beta minus 3. And what is the minor of negative 2? So that is going to be beta. So if I add them up, I will get minus beta minus 3. So this is our S2 and determinant already I have. So now I'm going to do, I'm just trying to construct this matrix out from here. So I'm just multiplying this entire equation with a to the power 4. So that will give you, the first term will be a to the power 7 minus S1 a to the power 6, then S2 a to the power 5, and minus determinant of a into a. Sorry, a to the power 4. Now I'm going to substitute S1 and S2 there, so that will give you a to the power 7 here. S1 is beta minus 1, so I'm just writing beta minus 1. S2 is negative beta minus 3, so that is going to be negative beta minus 3 times, let me write it by multiplying this thing. So negative beta a to the power 5 minus 3 a to the power 5, and determinant of a is minus 1, so that will become plus a to the power 4 is equal to null matrix. Now this is a to the power 7 minus, this is by the way a to the power 6 here, minus beta minus 1 a to the power 6 minus beta a to the power 5, and I bring all these two terms on the right hand side. So 3 a to the power 5 minus a to the power 4. Now you notice I can use this fact that the determinant of this matrix is 0. So I take the determinant both sides. So I will get a to the power 7 minus beta minus 1 a to the power 6 minus beta a to the power 5 determinant is equal to 3 a to the power 5 minus a to the power 4 determinant, and that is going to be 0. So from there what I can do, that again I can take from here a to the power 4 is a common factor, so we get 3a minus I, determinant is 0. Again determinant of a is minus 1, so that determinant will become 1 here. So I am getting finally 3a minus I determinant is equal to 0. So in this method, one thing you can understand, that we are not getting an extra factor which was disturbing us. So this method is also one valid method, and if you try to explore more, you can try this method. And okay, so let's solve it. We further solve it. So this is the a I have. So let's say find 3a minus I. So 3a minus I will become nothing but 3 beta minus 1, and this will become 0 minus 0, then 3 minus 0, then 3 to the 6 minus 0, and 3 minus 1, that is 2, minus 6, then 3 is a 9 there, and then again 3 there, and minus 6 minus 0 is going to be minus 6. Now this determinant is 0. You notice what will happen if I simplify this thing, we get 3 beta minus 1 times some constant here, that is going to be minus 12 and plus 18, so that is going to be 6, and for 0 that is 0 here, there is no such issue, and here also you get 0. So you see a little bit easier calculation, we getting 3 beta minus 1 is equal to 0, and beta is equal to 1/3, and so 9 beta is 3. So this is one way is also applicable. If you learn this kind of things like a characteristic equation, if you know very well, you can try it this way. So I recommend that you should try every question in 1 or 2 ways to explore better mathematics inside it. So see you in the next video with some other JEE Advanced question in TWBW, the why behind what. Till then, stay math active.